In order to reduce an alkene to an alkane, you have to use H2 gas along with a metal catalyst, for example, the palladium carbon catalyst. How this works is both the alkene and the hydrogen gas sit on the surface of the metal. The hydrogens then add via syn addition to create the alkane. Some miscellaneous facts about this reaction are the more substituted the alkene, the less reactive it is. So for instance, if we replace these two hydrogens with two methyl groups, that would make the reaction go slower. But if we replace these two methyl groups with hydrogens, that would make the reaction go faster. Also, because a transalkene is more stable than a cisalkene, the reaction of the transalkene will release less energy than the equivalent cisalkene. If it starts out higher energy, then it will release more energy. A similar reaction will occur with alkynes. For example, if you add two equivalents of H2 gas to an alkyne along with a metal catalyst, that will give you an alkane. This reaction will always go all the way to an alkane instead of stopping at the alkene. However, if you want the reaction to stop at the alkene stage, you need to use a poisoned version of the metal catalyst, called the Lindlar Catalyst. This will use a similar mechanism to the previous reaction, and it will always result in a cisalkene, because the two hydrogens always add from the same side via syn addition. If you want to create a transalkene instead, you need to use a different method. This method is called dissolving metal reduction, and it uses sodium metal along with liquid ammonia. In the first step of this reaction, the sodium metal turns into a sodium ion into an electron, and that electron will attack one of the carbons from the alkyne. This gives you a radical on that carbon and a lone pair on the other carbon of the alkyne, creating a negatively charged carbanion. The lone pair then attacks a hydrogen from the ammonia to give you a vinyl carbanion, which is a double bond with a radical on one of the carbons. Next, another sodium splits into the ion and the electron, and that electron will attack that radical to give you a lone pair and a new carbanion. This new carbanion will also attack a hydrogen from an ammonia to give you a transalkene, your final product. An important point to note about this reaction is that it will always give you the trans version of the alkene, because the trans version is more stable due to the two R groups pointing away from each other. In summary, you can reduce an alkyne any of three different ways depending on which reagents you choose to use.